Hello. How's everybody doing? Woo! I think I'm losing my voice, so I apologize. My name's Anthony. I work at HashiCorp. I've been there for nearly 3 years. I'm an engineer in the internal platform services organization, and we support services on multiple cloud providers in over 20 regions. I've been using Temporal for about 2 years, and before HashiCorp, I worked at companies like Auth0, Envision, Atlassian, and other startups and other businesses, mostly in sort of like productivity, DevOps type of roles. I shouldn't admit this, but I know that a theme that you might have seen in a lot of talks is trust, so I'm just going to be honest that my headshot is made by AI, and that's not really, shouldn't be too surprising because, well, to people who know me, because if you know me, I wouldn't just stand in the middle of the street with my back to oncoming traffic. And I certainly wouldn't wear a backpack that looks like it's made out of seat belts. So last year, at last year's replay, we talked about our experience adopting Temporal, and I said something about feeling like we gained a superpower. And so I thought it would be cool if I expanded on that. I was like, oh, what are some other examples of things that we've found that have been really amazing? But as I thought about it, I realized no superhero story really is complete without super weaknesses. And in this talk, we're also going to be talking about not just superpowers, but also the weaknesses that we've had to overcome. I keep looking, wishing I could see the slides on the big screen for some reason, so I apologize. I look weird that I keep looking. Wouldn't this picture be great, though, in like a talk about pager duty? Or parenthood? Anyway, we're engineers, right? So what would we do if we didn't have problems to solve every single day? So first, I want to start by sharing our approach to the platform. I'm going to stand in front of the podium. I hope that that's not too weird. I know people like to stand in the middle of the stage, but I don't. So I'm hoping that this will help as we proceed with our talk. If I mention any terms that sound unfamiliar, I try to use words that are sort of both opinionated and unused, which is not easy to do across multiple cloud providers and technology stacks. But basically the idea behind designing a platform is there are two domains. There's kind of like abstractions like the ones shown on the left, and in my experience those are often, at first anyway, only defined implicitly, or maybe you define them as part of your unified tagging strategy or something. Or alternatively, maybe you decide to build some monolithic platform application, and then you have one team being the bottleneck or the gatekeeper for like every single platform feature you want to build. So I guess I would expand on just abstractions just with an example. So this is like a product service. So we have a to-do list application, and you can tell it's a product service because it has a chat GPT proxy, because that's what our investors wanted. But I mentioned that just to highlight this is not a platform service. This is like an application built for the product. And so we would call this a component. Maybe it's deployed to like several zones. It has different resources associated with it. And it's owned by the to-do list team. And then these are capabilities, like I mentioned. This is kind of the other side of platform engineering. And you notice maybe we have a data store worker, maybe we have like a CI/CD tool, but these are also just components deployed by the platform. So the idea is like our abstractions make sort of like the problem of how do you build the platform orthogonal to the organization of the platform itself, and it forces platform engineers to think like platform users, which doesn't happen like by default. So yes, from the perspective of a user, these things are intrinsically linked, but the problem is that platform engineers can't even see themselves as users of the platform, and as a result, you end up getting like 2 or 3 solutions to the same problem. So ultimately, having these abstractions be kind of the core of what you're building facilitates the independent development of capabilities by domain experts themselves. Even teams historically considered product engineering teams can operate platform capabilities. So for example, like running platform services for internal and external tenants or something like that, and not having to reinvent or learn things, 2 times on 2 different teams. So this is kind of our core system we use a managed Terraform system like HCP Terraform or Terraform Enterprise, and I'm sorry, like this, I know it looks like a product pitch because I work at HashiCorp, but I'm just a platform engineer and I like to use homegrown tools like everyone else. We just happen to sell this one. But the important things on this slide are the component is kind of like a unit of deployment, and then a zone is like a spatial element. So maybe, if you saw Sergey's talk, maybe you'd think in terms of cells or something like that. It's the same concept. Our kind of core platform engine is just really good at deploying components to zones. And so I kind of like to call this like it's kind of like a bootstrap compiler approach to building a platform. This is the thing that has to be in place before you can build anything else that makes your life better. And on that note, like speaking of making life better, you may be wondering, like, why isn't he talking about Temporal? And that's mainly because Temporal is, or durable execution more broadly, is really an implementation detail for us. And so that's what I'm going to talk about next. Basically, I guess the main takeaway from all this is, I think you have to be aligned on sort of like your foundation, but you will have to solve durable execution before you can scale this model out. So I'm going to walk through some of the, I guess, things that worked really well for us. Sometimes this clicker doesn't work. That's why I'm kind of awkwardly. So this is kind of like a maturity model that I invented in a slide. And it sort of assumes that you're starting from scratch. So like, let's say you have an entirely new requirement. Maybe someone said, can you deploy this type of VM with this tool running on it for me? And you don't even know if it needs to be automated yet, maybe. Maybe you just do it manually at first, or maybe you find, oh, this is happening a lot, we should figure out a way to do this automatically, it's wasting our time. And the real point of this slide is I want to focus on stage 3 and stage 4. So stage 3 might be, okay, I have a full script, but maybe I need to run it manually because it's flaky, or maybe it requires really elevated permissions, or maybe it's too risky, I need to do cleanup if it fails. And then stage 4 is where you can push a button and close your laptop and walk away. And I think the idea that I'm trying to show here is, with workflow durability provided by Temporal, it becomes a lot easier to get to that stage 4. It really shortens the distance to getting to the unattended execution stage. And you can go further, but you don't have to. So there's an example, without going into too much detail. We had a process that was like Confluence pages and scripts, and it would take like 3 members of the team on a video call for 6 hours to do. And every time we did it, it was a nightmare, and we had to update all the docs and everything. And we had 2 engineers on our team spend a few weeks turning it into a Temporal workflow, and now it just runs within 30 minutes. You just push a button, basically. That type of thing is possible. So I'm going to show some examples. And the idea here is, in this example, we are augmenting, or in some cases, replacing the normal autoscaling lifecycle with like AWS autoscaling group. We're replacing the instance lifecycle with something which is more durable, with additional behaviors we couldn't reliably automate any other way. Like previously, we used to like run commands on the instances themselves, which is totally not durable. The instance can't keep itself around. because if it crashes, then it gets terminated. So this is just, really the lesson is just find the shortest way to get control into something durable, like a worker. And the only problem here is that we've actually had to, now we have to find all the edge cases because the workflow always runs, and the obvious edge cases are things like, okay, the instance doesn't exist anymore, so that's obviously a terminal condition, but sometimes you just see things like, oh, the instance was created, but it never got a network interface. Like these sort of edge casey things where you're actually pointing the finger at your cloud provider, which is a good place to be. I mean, it just kind of shows you that your automation is more reliable. This is a example pattern that is really, really powerful. And this is probably the coolest thing I'm going to show you, which is like, you can really automate just about anything with this trick. And it's just returning an error when you haven't figured out how to do it. And so this is kind of like the to-do dependent long-running workflow, or to-do in the loop. It's missing a return nil at the end. Honestly, this is like, sometimes you just accidentally do this. You'd forget to handle some error or something, but this is the original source of when we said we felt like we gained a superpower, because just the fact that we could fix something on the fly and have the workflow resume was amazing. But yeah, it can be noisy if you do it this way. A better way is just pretend your bug is a background check, which is not a weird metaphor, even though I like weird metaphors. That's just use the background checks example app to see the kind of human-dependent workflow. You can, I don't know if this is readable, but if it's not, basically this is just a signal that like a human can resume the workflow. So the idea is like, maybe there's some really, really rare situation that only happens every once in a while, and when it happens, you would like to be able to handle it automatically, but maybe you haven't figured out how to yet, so you just like log an error and have someone on your team look into it and then push a button whenever they're done. This can actually be really useful just because you don't really have an excuse not to automate the rest of your workflow, because you can take all the parts that you were afraid of trying to automate, and you can just put a to-do. So this is another basic capability. I think probably a lot of people are familiar with this already, but it's very simple and very powerful, like a lot of these examples. This is just like collect, undo steps as you go through your workflow. I don't know why I went, okay, sorry. I do want to point out on line like 21, 22, 21, you do need to use a disconnected context if you want your activities to be executed after the workflow is canceled. And similarly, this is probably different in other SDKs that I don't have that I'm not familiar with, but you also have to use like activity options to ensure that the activity will run during cancellation. But the other thing I wanted to call out here is maybe to inspire you to also think about other things you can do beyond just reversing your changes or doing undo steps. Like you can collect more diagnostic information, you can take a heap dump, or send a Slack message. Like your compensating actions don't always have to just be focused on undoing. You can also maybe take more data from the time that the failure occurred to help you understand the impact a little bit better. Okay, another example of things that are super useful to platform teams, and this is just combining the synchronous feedback that a workflow caller might expect from some sort of like resource destroy request, for example, but maybe you have a data retention policy that says you can't actually destroy it for, let's say 90 days or something. So the idea is just do all the, remove access, delete all the like, I don't know, subnet groups and security policies and things, but keep the encryption key, keep the data, and then launch a child workflow that sleeps for, let's say, 90 days, and then cleans it up. There are other approaches. I'm really just calling out that this is super useful and really easy to do. I think that's the gist of a lot of the stuff that I presented. It's actually kind of, I don't want to say I have imposter syndrome, but it's like you're presenting things that seem easy, but you also, like, that's the point, I guess. I'm not trying to show you how many complex, hard things I can come up with. On that note, these are complex, hard things. So I would like to close the rest of the talk and focus on some of the ways things kind of can go wrong. And I really wanted to continue the superhero theme by using superhero weaknesses, because I assume that there would be funny ones, but there kind of aren't. There are two that are funny, or three. One is Spider-Man is literally weak against bug spray, which is just... And Green Lantern is powerless against the color yellow. So, like, you could beat him with an emoji. And then the third funny one I didn't have a picture for, but apparently there's a super character whose weakness is lack of self-confidence. So if you can make him doubt himself, then whatever. So durability learning curves. This echoes, I think you might have heard the word trust said a lot these past couple days, but I think that part gets missed by some people. Like, you can learn the tools, or you can learn the SDKs and the architecture, but then you have to unlearn the habits of, like, writing. Without durable execution, you're doing a lot more work to write fault-tolerant code, or you're thinking about your problems in terms of, like, I am going to define this as a state machine so that I know, that it's not going to end up in an invalid state or something. But you have to unlearn some of that stuff and just play by the rules. And you have to trust durable execution, and that's hard for people. And if you don't, then you risk undoing the benefits that you would otherwise gain by using something like Temporal. And similarly, workflow consumers, they may want to wrap your entire workflow in, like, an HTTP API, and then they may want to, like, have their own retries and failure handles, or things that, if it were me, I would maybe build my own workflow to interact with, your workflow. Those boundaries, it's kind of like, if you're familiar with, like, the days of JavaScript before async await, or even with async await, but, like, there's always that point where you have to take all your promise stuff and put it back into callback hell, and then you have this, like, callback hell layer. I don't know if that resonates with anyone. That's just what I think of. The UI is really nice. It gets updated frequently. It's very useful. I don't want anyone to use it. Mainly because it's kind of like, actually Chris, wherever Chris is, Chris Ludden said this to me yesterday, but it's like, this is what I think of now. But it's almost like it's more, as a workflow author, if my workflow consumer is trying to use the UI, and Chris didn't say this, I'm paraphrasing, so I apologize if I make you sound dumb, but it's almost like your user trying to use, like, pgadmin or some visual SQL client to access your services database. Like, I don't want you to look at the Temporal UI to debug the workflow that that my worker is running on your behalf. I don't really want you to look at it. I certainly don't want you to try to cancel it or reset history or anything. So that's been a challenge, but we sometimes have to give people what they want. We did not put any effort into errors, so when an error is logged, it looks hideous. I'm not going to dwell on that too much, but you can handle this in a variety of ways. You could even not make errors a part of all of your result types and things like that. And then this is like a humble brag, but we started leaning on other parts of the system more because we were deploying more workers and having more resources under management by the platform and more regions and more zones and all this stuff, and we didn't actually solve like sort of the systemic, and I'm not even talking about scaling like in terms of technology, I'm talking about like people, systems, do the teams actually have access to the different accounts or tools or whatever. Like we have done a lot with a small team, but we've missed some of these other things. So I just wanted to throw that out there. Now I'm going to try and fly through this. I appreciate everyone sticking around. These are some human stories. Not stories, but these are the kinds of sort of like perspectives. And this is not an insult. These are like the smartest people in the movie. Or the most articulate, I guess. But yeah, so these people, as I mentioned, like they need to unlearn habits. They haven't been converted to the way of durable execution, so they have to unlearn some habits. These people will tank your project because they're used to things being a certain way, and maybe their whole career within your company is based on having access to certain things, and you can say, yeah, but you don't need that anymore. Like, but then what will I have access to instead? So you have to, you can't swing the pendulum all the way away from other things that you may be replacing with temporal without solving this problem. These are your teammates who are going to be on call for your workers, and they might be keeping the lights on, and they might not have time to play with the cool new stuff. And this one especially, but all of these they're more like like software engineering manager issues, but it takes a village to build a full stack app. And then this is just, I think, reiterating what I already said about like our tools. We didn't necessarily scale like our processes, our support processes for supporting other teams. So you can't forget about that stuff either. So now I'm going to wrap up. I have 3 minutes and 52 seconds. I don't know why I told you that. So really, if you're like a platform engineer, you're hardening things, really you're talking about adding durability, handling errors. And durability really, when you invest in it, it really speeds up your ability to create and evolve workflows. When you're in a situation where you cannot guarantee something to be durable, then you can try to find the shortest distance to get control into something which is durable. You can skip the hard parts. Durability gives you that. And I haven't done this myself, but let's all have an informal book club where we all reread all the examples and think about it from the perspective of a platform team or a platform user. This one is just an example of how easy that could be, and also encouraged you to, not just think about reversing changes, but also like take advantage of the fact that you can do whatever you want. And that's true in life, by the way. Yeah, that one's obvious. I'm not going to read the slide to you. I'm sorry. And then last year we talked about gluing stuff together using like kind of CRUD workflows, and that's really powerful too. But I didn't even mention it because you can watch a whole talk on that. Finally, just general advice for platform engineers. I think you can't expand and move different teams orthogonally without having sort of and this is obvious probably to a lot of people, but these things need to be defined, and not only implicitly, but like you need to explain why things are the way they are. And you can start your platform with just the basic, what I like to call the bootstrap compiler style platform. Platform capabilities, I don't like when platform teams just become sort of gatekeepers and like you open a pull request to my like Terraform monorepo and I approve it and then it breaks production and then I think that it's better when platform is built on software and that software is operated by people who understand the underlying technology the best. And then this is just a general observation, but I think platforms, I think Sergey mentioned like control plane, everything like temporal cloud control plane stuff is workflows. And it's true. Platform engineering is, control plane engineering. And it's basically just being creatively lazy in the face of repeated requests. And for those, durable execution is the best option. Thanks. I'm actually watching the timer and I'm like waiting for it to go to 1. I'm like 5, 4. I'm sorry. I did really good on timing this, so it's like in the back of my mind. Yeah, that's it. Thank you.